Hey folks, I asked you to work the problems that had to do with permutations yesterday. And then when you got to the point where it felt like things were changing to a different formula, then I wanted you to stop. And I really appreciated your flexibility yesterday with that little stand up in front of class. And we're going to look at that one more time, okay? Like we did right at the beginning of class today. But here in number 6, it says that we're going to choose some people from a list to be give some speeches, and it says, "What's the probability that these three kids are the first three speakers in any order?" So these words right here, "in any order," are really, really important. Let me zoom out and show you the little flow chart that we've been trying to use. Okay. If we thought order was important, we used the permutate formula. If we thought order is not important yesterday, we stopped and we said, okay, that's the end of our homework assignment. And so number 6 is the first time I see that order is not important. And so this is a new formula over here. And I want us to understand a little bit about that formula. So let me just spend just a minute longer talking about the roles that we had yesterday. So my scenario was I was going to watch the class as people raised their hand to be volunteers to go talk to Miss Sawicki about our advisory program and how can we make it better, right? The first hand I saw shoot up would get the stick. They'd be like the lead person. They'd be in charge. The second one was going to get a feather, which we made a story about what that responsibility was. And then the third person would be the secretary. Okay. Now, let's say we were going to allow them to rearrange the roles for this group that's going to go talk to Miss Sawicki. Well, this represents one way that we could have the situation going on, right? So, like, let me make a little tree diagram. Yesterday we tried to do this. It was a little tricky, right? And so let me try like this. Let's see. It could go like. The first person, right, was like, well, we had a hard time getting initials down that were unique in fifth period. So we just used A, B, and C. Okay, so the feather could go to A, B, or C. And then what we could do, if A got the feather, we said that down here, then it would go something like for the stick, I don't know if I'm doing this in the right order, but the stick could go to B or C. And then the notebook, if that's the way it went, then this would have to be C for the notebook. And if it went A, feather, C, stick, then it would have to be B for the notebook, right? And we could make a tree diagram just like this, right? So it wasn't, super tough to make a tree diagram, but it was a little confusing, right? It took us a little time, and we only had 3 people standing up in front of class. Let me see if I can just finish this off real quick. I think we would have something like A here, and we'd have B there. So how many different ways could these combinations happen? Well, we could have this situation, this situation, this situation, this situation, this one, or this one. That makes 1, 2, 3, 4, 5, 6. We said that's the same as using the 3 permutate 3 formula, right? So what does that look like? It looks like 3 factorial all over 3 minus 3 factorial. Since the numbers are the same, this is where the R, this is where R was, and this is N, the total number that we have in our situation. And that came out to be 6. Now, that's where the order mattered. Order matters, right? If the order doesn't matter, then we only have one, group of people. We had those 3 people that stood up there. They're not going to really have a role. They're just going to go talk to Miss Sawicki. When Miss Sawicki sees them come in, she doesn't really put them in any particular role, or it doesn't matter. They're just a group of 3, so they're going in as one group. And so somehow we need to change this 6 back to a 1 because there's only one group like this. And the way you do it is you take the R value and you divide by R factorial right over here. So I'm going to put down 3 factorial right over here. And that would divide the 6 out and make it a 1. Now, I don't really want to put it right here because this was order matters situation. Let me zoom back out and let's put it where it belongs in our flow chart here, okay? So what I'm saying is the formulas are going to be identical except for we're going to divide by r factorial. Let me put the formula down. So over here, we're going to have n factorial all over n minus r. See, that's the same as permutations. You start out the same way as permutations. But if you divide by r factorial, it takes out like that littler group. It takes out the way that you could rearrange those kids, right? So dividing by r factorial is like dividing by 6 back in our problem over here. And you would have ended up with 6 over 6, which would have been 1. You had one group of 3 kids. Now, I'm going to try that with our problem that we're looking at up here with the speeches. Okay, so let's zoom back out here for a second. I'm just going to try to reemphasize this. So in this problem on number 6, when we're looking at our flow chart, it says right down where I circled it. Remember where that red circle was? Let me put the circle back in the right place. In any order, okay? So I know it might be kind of really small print on your screen, but it says in any order. So when I go to my flow chart, I'm going to go over here to the combination formula. And let me try and zoom back in right down here, and we're going to see if we can apply that formula. So what do we want to do? We have a group of 3 kids, Denny, Kelly, and Chaminade. That's like, it doesn't matter which way we rearrange them. We want one thing to happen with that group of 3. So my probability, and if you don't have this down in your notes, I definitely want you to put it down. The P stands for probability, okay? And when you see it in these kind of probability situations, of those 3 kids, D, K, and C being the first 3 speakers, doesn't matter what order they go in, okay? So DKC, first 3 speakers, okay? That's the way they might write it. Okay, so we want the one with the probability of that, okay? Well, there's only one group of 3 that involve Denny, Kelly, and Chaminade. If there's anybody else in that group, it's not the same group of 3, right? So I'm going to say my probability is 1 out of, now I need to figure out how many different ways could we have groups of 3 from this group of, let's see here, 1, 2, 3, 4, 5, 6, 7. This number 7 is our n. N equals 7. That's the total number of people, okay? The R in our formula is 3 because we want a group of 3. This is like what we want to have happen. We want a group of 3, okay? 3 in the smaller set. I'm going to call it set or group, okay? So what we have going on here is 7 choose 3. Okay, so how do I use this formula right up here? I go like this. I go 1 over, because 1 for my probability is only one group of 3 out of this set of 7 people that involves Denny, Kelly, and Chaminade. Okay, that's why I got a 1 right up there. Now down in the denominator, I'm going to go like this. I'm going to go 7 factorial all over 7 minus 3 factorial times 3 factorial. Now, what do I really need to focus on? I really need to focus on my denominator. Let me zoom the heck in on the denominator. This part right here is called the denominator. Okay? The numerator is super simple. The numerator is 1, so why mess with that at all, right? So the author, I'll just say it one more time. The author wants us to understand that factorial means, so the denominator, I'm just going to do the denominator right here, is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then right here in this part of the denominator, there's like, a denominator, inner denominator. That's a little confusing. 7 minus 3 is 4 factorial. So let me put that in red. This right here is 4 factorial, right? So I'm going to write that down right here. 4 times 3 times 2 times 1. Okay, so this right over here is obviously 3 factorial. I'll put that in blue. 3 times 2 times 1, right? So are there some things that are going to cancel out? Oh, without a doubt. 4, 3, 2, 1 is going to divide into 4, 3, 2, 1, resulting in a 1 right there, right? The 3 divides into 6 2 times. So I've now divided the 3 into the 6. So you can do multiplication and division in any order you want. I'm choosing to divide before I start multiplying to keep my number small. Oh, look, the 2 will divide into the 2 one time. So now my denominator here is just a 1, and we've got 7 times 5. So all of that stuff, all of this denominator just became 7 times 5, which is 35. So my final answer is 1 over 35. Now, I know this arithmetic stuff seems like, what? I not only have to choose the correct formula and know how to use the formula, then I got to know how to do all this arithmetic. So I'm going to show you a little shortcut. Okay. So what I'm doing on my other screen over here is I'm opening up Desmos. Okay. You know how much I love Desmos, right? And I want you to go to the graphing calculator. And we knew the numerator was a 1, right? So I'm going to go 1 divided by. Now in the denominator, let's look back at our problem. We had 7 choose 3. Okay, this is not really the way the author wants you to do this, but I'm going to show it to you because I know this feels a little bit overwhelming. So I come down here and my picture's in the way, and so is this thing. I need this little menu right here. So open up that menu and then go over here to function. And then I want you to scroll down to N choose R. Now you need to know how to use N choose R. And as soon as I started clicking on the screen to move my pictures around, I put N choose R in the wrong place. So I'm going to cut it and I'm going to put it down the denominator. It's got to be down here. And then I want right here 7 comma 3. 7 comma 3. Now you might say, oh, wait, the program is not going to let me type in 0.0285 because the program wants us to simplify down, simplify the fraction, right? So let me drag that onto the screen over here. And you'll see that I simplified the fraction down to 1 over 35, right? It says simplest form, the fraction. Why do they ask us to do that? Because they really want us to understand this stuff about exclamation mark meaning factorial and all that kind of stuff. But if you're feeling overwhelmed, you can always have Desmos calculate this as a fraction by hitting this little button right over here. And it converts it to 1 over 35. So this is how we do the choose problem. Let me just kind of summarize what I decided to do here. I'm going to zoom out. If you feel like, man, I got it, Nelson, I don't need to listen anymore. But if it's a little confusing, here's what I did. Okay. We have either a order matters problem or we have an order does not matter problem. I read in my problem right here that in any order. That's how I ended up over here with the combination formula. This is our combination formula. I need you to add that to your notes. Then I had to figure out, well, what was in the numerator? Well, there's only one way to make a group of 3 that involve these kids. So I'm going to put 1 in the numerator, and then the denominator, I need to figure out how many different groups of 3 could we have out of this 7 when the order doesn't matter. So I'm doing 7 choose 3, and you could apply the formula on Desmos, or you could do the factorial stuff if you want that practice. And 1 over 35 is the right answer. So I hope number 6 makes sense. We'll try to finish off the homework today in class, and then I expect you to work on Alex. Thanks for watching.